In this lesson, we will focus on making mole calculations using the unit analysis method, using some basic conversion factors. If you are not yet familiar with how to generate a conversion factor off the top of your head, please refer back to the previous video lesson on this topic. All right, some reminders for you as we get started. The first thing you need to remember is to write down the starting values over 1. Then you're going to multiply by an appropriate conversion factor or several conversion factors to get these final answers. Finally, cancel out units to get the desired answer, and I should also mention, round your final answer to sig figs with the correct units at the end. Let's get started. Our first question we're looking at today is how many sodium atoms are contained in a sample that is 0.120 moles of sodium. So starting off with what they're giving us, 0.120 moles of sodium, and placing that value over 1. The next thing I'm going to do is multiply by a conversion factor that gets me from moles of sodium to atoms of sodium, which is what I'm looking for here. So 1 mole of sodium, because we're just dealing with single elements here, contains 6.022 times 10 to the 23rd atoms of sodium. From previous lessons on this, one thing to remember is that if we're doing our conversion factors correctly, the units we are using should cancel out until we're left with the units of interest. Again, we're trying to get to atoms of sodium. All right, so if we plug that into our calculator correctly, we should get an answer of 7.2264 times 10 to the 22nd atoms. That's too many for our particular answer here. We can only have 3 based on the 3 sig figs from 0.120. So I'm going to round that out to 7.23 times 10 to the 24th. Do not forget the 10 to the whatever power that you get, and then label that appropriately. So atoms of sodium, that will be our first example. As you are taking your own notes, I highly encourage you to pause the video, record the information, and then go back and watch the pieces that maybe you need a little bit more explanation on. Okay, because sometimes it's hard to do both. All right, in this next problem, we have how many moles of potassium are contained if in a sample that has 1.25 times 10 to the 21st atoms of potassium. So 1.25 times 10 to the 21st over 1. In all of my answer keys that I provide for you throughout this time, you are going to see this set up exactly the same way. I will try to cancel out all my units so that you guys have an advantage here in learning this skill. All right, again, we're trying to go from atoms to moles, and because we're only working with atoms right now and compounds are not involved, we can say that there are 6.022 times 10 to the 23rd atoms of potassium in 1 mole of potassium. All right, again, if we're looking at this, units are going to cancel out beautifully here. Atoms of potassium cancel out. We're left with moles of potassium, which is what we're looking for. And so now if I plug that into my calculator, the one thing I have to remind you of is make sure you're using parentheses. So put that 1.25 times 10 to the 21st in your calculator, hit equals, and then do a divided by. When you divide, put the 6.022 times 10 to the 23rd in parentheses to get this next answer. So when I plugged that into my calculator earlier, I got an answer of 0.0020757, which exceeds my sig figs. So I'm going to write this out as 0.00. Again, those zeros do not count. They are leading zeros. I'm going to go 208. And then throw my units on there, atoms, potassium, as my final answer. All right, next example. How many moles of calcium chloride are in 1.39 times 10 to the 19th formula units of calcium chloride? In a previous lesson, I explained that FU is the only time in chemistry that it's appropriate to write down FU to your teacher, but FU stands for formula units. Formula units, that abbreviation can only be used with ionic compounds. Now, in both high school chem and college chem, we'll pretty much just use compounds to say anything, whether it's a molecule like water or if it's a formula unit like calcium chloride. These were just some old notes that I had previously. All right, so again, starting off with what we know. We know we have 1.39 times 10 to the 19th. I'm going to change that to compounds of CaCl2 just to make it less confusing. Putting that over 1. I'm just going to do this a little bit different here. And again, I'm trying to get to moles. Well, the nice thing about this is compounds can convert directly to moles, right? There are 6.022 times 10 to the 23rd compounds of CaCl2 in 1 mole of CaCl2. Again, that mole conversion, you can switch up the units that you're using, but you just have to be very careful when you're doing that to make sure that the conversion is still true. All right, so that works. Now we have moles of CaCl2, which is what we're looking for in our final answer. And so calculating that out previous to this, I got an answer. And we have to round that to sig figs, so we need 3 sig figs, 0.0000, yikes, 231. Now, I do not like that as an answer in terms of the way that I'm writing that, so I'm going to convert that over into scientific notation, which we should be doing anytime that our numbers are really big or really small, so we should just be comfortable with that. So making that or turning that into scientific notation, I'm going to just show you that real quick. I'm going to slide that decimal 1, 2, oops, that's fun. All right, try that again. So I'm going to slide 1, 2, 3, 4, 5 to the right. And this is a number less than 1, so that's actually be 10 to the negative 5th. So I will have 2.31 times 10 to the negative 5th moles of CaCl2. Now I could just write MOL CaCl2. And actually I will go back and erase that just to make it a little less work for you guys. But again, if our numbers are really big or really small, let's just get into the habit of writing those out in scientific notation to make things a little bit easier in the long run. All right, next question in these notes. Let's try to get through these a little bit faster. How many total atoms are in 3.58 moles of sodium chloride? So starting off with 3.58 moles of NaCl over 1. I need to get to total atoms, which I'm working with compounds, so anytime I'm in compound world, I need to get to compounds so I can convert to atoms. So I'm going to use that conversion factor of 1 mole of sodium chloride has 6.022 times 10 to the 23rd compounds. I'll just put CNaCl. And now I can say 1 compound of NaCl has 2 total atoms, right? Every compound of sodium chloride would contain 1 atom of sodium and 1 atom of chlorine. So now if I go through and cancel out units, again, which I'm always going to do first to make sure I've set it up correctly, my moles of sodium cancel out, my compounds of sodium chloride cancel out, and I am now left with atoms, a total in those compounds. All right, so finalizing that answer, again, all of my examples I'm giving you today have 3 sig figs. So my final answer here is going to be 4.31 times 10 to the 24th atoms. Now I don't have any other units outside of atoms because it was just looking for total atoms. All right, a couple more examples here. How many total atoms are in 18.95 moles of calcium hydroxide? So we're going to set this up pretty much the exact same way. The only thing that's going to be different here is we're going to, at the end, have a different number of atoms because we're starting off with a different number of moles, and also calcium hydroxide itself has more atoms in every compound than sodium chloride did. But process, way we're thinking through this is going to be the same. So we have 18.95 moles of CaOH2 over 1. Always start with your starting unit over 1. Moles of CaOH2 have to go on the bottom to cancel out. And then compounds, we're going to have 6.022 times 10 to the 23rd compounds. And again, I'll just abbreviate it with a C. It's just, it's a very similar conversion factor to a dozen. If I have a dozen donuts, I have 12 donuts. If I have a dozen marbles, I have 12 marbles. So regardless, you just have to know your conversion factors at this point. All right, and now I'm going to say that one compound of CaOH2 has a total of, now I need to count them, there are 2 hydrogens, 2 oxygens, and 1 calcium for a total of 5 atoms total in that compound. Again, going through and canceling out units to make sure that they do. Sometimes just doing this step saves you a hassle later on. Multiplying by everything on the top, dividing by any numbers on the bottom, gives me a final answer of 5.71. Oh, actually, this one has 4 sig figs, so 5.706 times 10 to the 25th. And then our units is atoms again. 2 more example problems here. How many atoms of carbon are in 4.19 moles of glucose, so C6H12O6? These questions can be very, very specific to one kind of atom, to the total atoms, so you're just going to use conversion factors that make sense as you go along. So again, starting with 4.19 moles of C6H12O6 over 1. And we know that 1 mole contains 6.022 times 10 to the 23rd compounds of glucose. Now this would be an appropriate time to use the term molecule, but again, trying to keep this as straightforward as I can. Now, when I'm writing this out, 1 compound of glucose, I don't have to be worried about the total number of atoms in glucose, which is 24. This only is asking me about atoms of carbon. So I can just write out that there are 6 atoms of carbon. And then I am in the units that the question is asking me for. So moles of glucose cancel out, compounds or molecules of glucose cancel out. I'm left with carbon atoms, which is what the question is asking me for. When I plug that into my calculator, I got an answer of 1.5139 times 10 to the 25th, and I need 3 sig figs, so 1.51 times 10 to the 25th. And now we will write atoms C because there is a specific unit we were looking for there. That was more than just atoms or more than just compounds. Something I want to clarify in any of these videos, because I am looking back and forth between screens, you're not seeing that on these videos, but that is, I have paper, I've got calculators. If any of these answers do not work out, you're going through and you're like, I did the math and it's not adding up, it's slightly off, or my answer is different, please send me a message and ask those questions. So that I can clarify that in an updated video, or I can send out a message to your classmates. All right, last one. So if I have 3.99 times 10 to the 24th atoms of hydrogen in a sample of CH4, which is methane, how many moles of CH4 do I have? So start off with what you know, 3.99 times 10 to the 24th atoms. Now I have to get to moles. I've been starting off with moles and getting to atoms. Now this is just that process in reverse. So I can go from atoms to compounds compounds to moles. So let's do that. In 1 compound of CH4, I have 4 atoms of hydrogen. Again, atoms of hydrogen have to go on the bottom so that they cancel out. Now I can simply go compounds to moles. So there are 6.022 times 10 to the 23rd compounds of CH4 in 1 mole of CH4. Again, cancel out those units before you take any additional steps. Most of the times that will save you so much time when you're trying to figure out if you've done something incorrectly. And then, sorry about that, I need 3 sig figs in my final answer, which should be 1.66 moles of CH4. All right, so at this point, you are encouraged to work on the assignment. Now that you have some brief notes on this, work on the assignment, check the answer key that is posted along with that assignment. And if you feel like you're ready, then go ahead and take your first attempt at that quiz. Now, if after you've taken that first attempt, it does not go well for you, I strongly encourage you to go back to the assignment and do some additional practice or reach out for help. Again, emailing me at elzimni@esko.k12.mn.us is going to be your most efficient way of getting a hold of me during these times. Good luck.